Hi, this is a recording of the purification by crystallization experiment for Chem 102. The first thing we need to do is, let me show you, is we need some cooled water, cooled distilled water, which I got right here working away. So I took and put about 50 to 75 milliliters of distilled deionized water into this squirt bottle. And we're going to want cold water as we do this, so I'm just going to keep it all nice and cold there. It's been cooling for a while. Next thing, we need to take our unknown sample here. Excuse me, get it to focus. And we're going to put this into this beaker and weigh it out. So let's go weigh out the unknown. So first I'm putting the beaker onto the weighing pan and I'm going to zero it out. So right now it reads 0.00 grams. And then I'm going to add about 10 grams of unknown. Didn't have quite 10 grams. Let me show you what there you can see the reading on the balance for the unknown solid. So to the unknown sample, we're going to add 10 milliliters of deionized water. It doesn't have to be cold water because we're going to start heating it up. So I'm just going to go over to the DI tap and measure out 10 milliliters in this small graduated cylinder. Then we're going to take a hot plate here. I'm going to turn the hot plate up to medium, which on this model is about 5 on a scale of 0 to 10. So we're heating it, and I've got a stir rod. So we just want to heat it until everything dissolves. So as you can see, right now we sort of got a baby blue colored sample or solution. So this will go for a little while. So it's been about 10 minutes since I started heating the sample and it's bubbling away. I don't know if you can see, but it is definitely bubbling, and I don't see any more solid in here. So I think it's time to stop the heating. And then I want to cool this down. Ooh, so we're going to pick it up for a second, let it cool a little bit. Just let it cool off the hot plate. I'll move the hot plate out of the way. Sometimes it's not a real good idea to put down something hot on a surface, so I'm going to put it on my notebook for a second, just to let it cool. And we're going to transfer that into an ice bath, which in this container I've got a bunch of ice and a little bit of water. The water serves as a really good heat conductor, so I'm going to take this out and I'm going to put it into the ice bath. And now, because of the lower solubility of alum, potassium aluminum sulfate, at a lower temperature, we should start seeing some precipitation after a little while. So let me here we get Here we get a picture of the liquid as it cools off. And I can't get real close. Whoops, let me get that out of the way. I don't think you can see, there's nothing really forming quite yet. But we'll give it a few minutes and it should precipitate out mostly alum, hopefully. Hopefully we'll leave the copper nitrate behind. So the boiled sample, the boiled solution has been in the ice bath for about 15 minutes. And the temperature has gone down to, if I read it right now, it reads, I would say it reads 2.8 degrees Celsius. So it's nice and low. And if we look at it, I don't know if you can see it here. Whoops, there we are. There's a whole bunch of solid in the bottom there. So we want to, I'm gonna take, whoops, let me put that there so it doesn't tip over. Put it back in the ice. While the sample was cooling down, I set up this Buchner funnel system. And it consists of a Buchner funnel. This is actually two parts. And this part has a perforated bottom, and we're gonna put a filter paper in there in just a little while. And this is just so you can separate the two parts and leave that sitting there. But it also has a filter flask, and the filter flask has this side arm on it that can hook up to a hose, which is just a little bit off camera, but right here there's a vacuum line. And so when I put this together, I can turn on the vacuum and pull the liquid through the solid that's inside the Buchner funnel. So let me, oops, I gotta hook it up to the other line. I had it in the wrong spot. But we're going to take a filter paper, so this is a filter paper, and put it on there. And then I'm going to just put a little bit, turn on the vacuum, and put a little bit of water on there just to make sure it'll sit down, that it's nice and low, or stuck to the bottom of the funnel. So the trick to transferring a solid is I put in about 5 milliliters of water this time, and I just want to keep it moving in the bottom of the beaker as much as possible. And then sort of in one, keep it moving, and then just pour it all at once. And it's if you don't stop stirring, the solid sinks to the bottom and then it stays stuck to the sides. And I still have some solid stuck to the sides of this, so I'm gonna wash down the solid with, again, about another 5 milliliters. And then I just want to stir real quick and pour. And now I think my beaker is pretty cleaned out. I don't see any solid inside there, at least nothing, not very much. So we've transferred all the solid out of the beaker into here. The one last thing that they do suggest is if you see a little bit of blue in this solid, you should wash it down. Let me show you what the solid looks like now. It's a little, you may be able to see that it's a fairly white solid. I think it's pretty clean, that we didn't get much copper nitrate in it, which would give it a blue color. I'm going to wash it with just a little bit of cold water. And then let it go. So we want to measure the amount of liquid in the bottom of the filter flask. So I'm going to turn off the vacuum, and I'm just going to break the vacuum by pulling this top part off, or maybe I'll do it here. This is easier there. And then I can take this off, and I'm going to separate the top and the bottom here so I can set this flat there and that flat. And then I'm going to pour the liquid, whoops, pour the liquid into this this graduated cylinder. Some of the alum will be left behind in this liquid, and so we want to keep track of how much liquid was used in making the solution, because that'll tell us how much alum we left behind as dissolved, as opposed to the dried alum. And I'll either provide the volume of this, or a picture that you can read the volume off of. So I'm going to put back together, and we want to dry out the alum, the purified dried alum, and the way we're going to do that is by putting this back together and just turning on the vacuum, and the vacuum will pull air over the solid that's inside here, and that will dry it, just like if you had if you hung your clothes out to dry on a windy day, it dries more quickly. And so if we pull air with the vacuum over the solid, it will dry. Oh yeah. Ooh. So it's pulling air over that. We're going to let it dry for about 15 minutes, and then weigh out the purified alum. We need to measure the mass of a watch glass to hold the purified alum. So tear this balance, put the watch glass on, and we've got a measurement of its mass. The sample's been drying for about 20 minutes on the vacuum, so I'm going to turn that off. And pull this apart. I'm going to tighten one. There we are. And we want to get, it's a little bit tough, but I can pull up the filter paper and sort of pull it over. And then we want to just slide the solid off the filter paper and scrape. You can see here the paper is kind of scratchy and dry. And these are the solid is not very dry. There might be a little bit of blue in the solid. Now we'll go measure this. The balance is tiered. We can put this on. And there we go. We have the final mass of the alum with the weight of the watch glass, and by difference we can figure out the mass of the alum. So that's it. Have a good time with this lab.